Hello, this is Ms. Gilchrist, Math Models B, teacher online. We are halfway through this semester. Scary and good news at the same time. I'm gonna skip 2-3 because I'm getting a little worried about time. And we're gonna go to 2-4. I think that's more important. We may have to come back and scoop it in. Let me go to the paper document and I'm gonna get started. Ooh, look at me with my eyes closed. Let's see. I'm gonna log on. I'm still here. There we go. Get the lighting right. I'm gonna try to do one video with both calculators. I do want to look at this lesson for a little bit. This is 2-3. I'm gonna try to skip through the main parts of this. One thing I do want to talk about is here. What does this mean if they ask you to solve a quadratic? Because this is the chapter where we're working with quadratics. But what does this mean if it says solve it? And this goes back to, like, solve is the verb and the noun is solutions. So when they say solve a quadratic, what we want are the roots. We want the solutions. So this is what we're, if you ever see this here, solve, then you're looking for those answers. You're gonna go to your calculator and find those points that are on the x-axis, the x-intercepts. So that's, just keep that in mind. But we're doing something a little bit different here. We're gonna look at the graph and what this is called, let me write it. Parameter changes. So we're going to change the parameters of the parent function. So when we talked about parent functions, this was one of the equations, y equals x squared, and it happens to be the parent function for quadratics. So let's just make sure we're familiar with those terminologies. And this is the grand A. This is the, the Adam and Eve, the original one. And I want to look at that graph. And then what we're going to do is we're going to change the parameters of it. We're going to change, we're going to look at what happens with the number in front of the x squared and what happens, this multiply, and then what happens if we add or subtract a number at the end. So that's what this lesson is about. So this is part one, that there's something else that happens. So maybe this will be better here. What I want to do is just do a simple graph of the parent function. And again, this is the one piece I haven't quite figured out how to direct you guys digitally, but at least follow and watch along with the graph that I'm doing and do your best with the tools that we have. But to get this, what I'm going to do is, how do I get the y? To get the y, take the x and square it. And these are just some ones that are selected. Now these are just selections from the domain. The domain is much, much, much bigger than this. This is just a few numbers that I've pulled from the domain to be able to graph it. Because I want to graph things that are on this graph paper and that are integers. I don't want to graph anything like 2.7. That's not fun to graph. So I'm going to take this -3 and go -3 times -3, -2 times -2, -1 times -1, 0 times 0, 1 times 1, 2 times 2, and 3 times 3. Now, as it turns out, all the numbers, all the output numbers are positive. And let's go ahead and graph this here. So -3 up 9. I happen to know this is 10 squares, so I just put 1 down instead of counting really up to 10. -2 and then up 4, 4, -1, up 1, 0, 0, 1, 1, 2, 4, and 3, 9. Now, and again, I use this trick that I mentioned with the axis of symmetry. This goes right through the y-axis is actually the symmetry that cuts it in half. So if there's a point 1 to the left, there's 1 to the right. 2 to the left, 2 to the right. 3 left, 3 the right. And then I connect those dots, and I've got a pretty good looking parabola. Well, okay looking. This is the parent function. So this is the basis. This is the starting point that we're going to use. And we're going to take this and we're going to shift it around and do some things with it. Now, let me show you just on both calculators. This is the Casio that we're used to working with, and I've been playing with it. So there we go. I'm in the graphing menu, and I need to get back to this screen. I just pushed the exit button. Exit sometimes is like go back. And I'm just going to push. I don't have to push the equals just after that. X. Oops, that did not push X. Let me delete that. X and then squared. The X is here and the squared is there. Then I like to do the blue one twice, and that's your basic looking one on the Casio. And on the Casio, really, it could be anywhere. The screen kind of changes around a little bit. And this is the TI-83. Let me turn it on. And this one usually you start by pushing the Y equals button after you get it all cleared or on or whatever. Y equals, and I want to delete that. This one is more like clear. Yep, I push clear and it's gone. And now just X. Now X is at a different spot. X is over next to the alpha, and squared is down here. So I had to push the X button and the square button. And there I've got X squared. Now I'm going to push over here where it says the word graph. And it looks about the same. So that's the parent function. So that's our starting point. What we're going to do is on the calculator, we're going to graph we're going to look at what happens if I take a number and multiply it 3 times. Okay, I just paused because I sneezed. I said something about multiply 3 times. It's not exactly that. I'm going to take the X squared and I'm going to multiply it by 2 and see what happens. And then I'm going to take a number that's even bigger and multiply it in 5x squared and see what happens. Now, this is what we call the ax squared. So in the first one, a is invisible. It's 1. Here a is 2, and here a is 5. So we're trying to find out what happens as a gets larger. What's going to happen to the graph? How's it going to change? Now, these are the instructions for Casio, and then I'm going to show you the other one. And I'm going to do Casio first. So we menu and we graph it. So we go to the graph, and I want to go back to the equation. So I'm pushing exit. I've got x squared, but now I'm going to push 2x squared. Now, instead of doing all 3, I'm just going to put those 2 at the same time. And it's going to go the first one and then the second one. So watch it. It's going to go 1, 2. 1, 2. So where was the second one? Aha. Now what does it look like here? So I'm going to go back to y equals. And there's my first one. And I'm going to go down. So I'm going to push this blue button. And here, 2x squared. Again, most of those are in the same place. You know, the 2's where it's here. The x is a little different, and that's a little different. 2x squared, and then I push the word graph. 1, 2. So both times. So here's what's going to happen. The first one, and I'm going to do this color code. So that one's in this black pen that I've got. So this is my best estimate of drawing this. You know, it's not perfect, but this is my x squared. Let me switch colors here. And then in red, I'm going to put the other one. Now the next one goes inside. Now it's still attached down here. It still has the 0, 0. That's the vertex. That's the same. That's the vertex here is at 0, 0. The vertex of all of these is 0. It's still anchored there. Now what happens to the third one? Let's see. What color I have here? Green. Yeah, it's showing up. Okay, so for the Casio, I'm just gonna go exit, go back, because I'm still in menu graph. Make sure it says draw, that makes you know you're in the graph one. So I've got x squared and 2x, and I wanna go on the third one, 5x squared. And then I'm gonna push this one twice. And it's gonna go in order, 1, 2, 3. Let me go back again, let's see. And draw it, oh. Let me move it around, 1, 2, 3. I'm just pushing this if I want to see the order. So the third one comes in there. And it's going to really not be that difficult here. I'm going to go back to y equals and go down to the third one. Oops, went too far. 5x squared graph. And there, the third one is on the inside. So what's happening to each one? As the A gets larger, the graph gets thinner, narrower, skinny. I'm going to use this word. This is the word I've heard seen most often on the STAR test, narrow, but it's thinner, skinny, however you want to think about it. Another word you really have to know about this is that mathematically what this is called a stretch. And, oh, I usually do this visual when I'm live. Let's see if I can. I will do something in a minute. I'm going to show. Okay, I'm going to put this on pause. I'm going to find something to show this the way I want to show it. Is it paused? Okay, I'm back. And so, yeah, what stretches a rubber band? So if this is like my parabola, when I stretch it, it gets thinner. And the more I stretch it, the thinner it gets. So that's why they call it a stretch. Ah, pretty cool. Okay, now let's go on to the next one. Well, you know what? I think I'm going to stop and